Welcome everyone to UWEC's Faculty Academic Staff Forum. Delighted to see a good crowd here today with us, and welcome to our folks online as well. My name is Erica Benson. I'm the Director of the Office of Research and Sponsored Programs here at UWEC, and I'm delighted to introduce today's speaker. Dr. Matt Haffner is an Associate Professor in the Department of Geography and Anthropology. His expertise lies in computational urban geography, and he is a four-season commuter cyclist. I can attest to this. I have seen Matt out in all weather cycling to and from work. Matt utilizes this approach in the study of cities and how they work, cycling as a form of transportation, and rural healthcare. Today, Dr. Haffner will share with us findings from a local survey on cycling safety perceptions, including where people feel unsafe riding a bicycle and how responses compare between demographic groups. So we will have time for questions and discussion after Dr. Haffner's presentation, so please be thinking of things that you want to ask about. And to our viewers online on Zoom, you can use the Q&A function at the bottom of the screen to ask questions. Our wonderful graduate assistant, Ethan, will read those questions aloud for us. So please join me in giving a warm welcome to Dr. Matt Haffner.
Thank you, everyone. I'm happy to be here to give this talk today and see you all here. So in this talk, I'm going to talk about two strands of my research. The more conceptual strand is that of reproducibility and replicability. And then I'm also going to talk how we can use this lens in the study of urban and transportation geography with a particular focus on cycling. So reproducibility is one of the cornerstones of the scientific process. And by reproducibility, I mean taking published results and then going back and using the same analytical procedures on the same data to confirm those results. And if we can't do that, we can't trust the results. And so this is a really, really important part of the scientific process. If we want to be trusted by the public, results need to be reproducible. And there are many dimensions to reproducibility. There are things like replicability, which means taking the same analysis and applying that analysis to new data to see if we see similar results. There are also other dimensions like extension. But the goal of all of this is to make the scientific process more robust and to make our results more meaningful, more useful to the public. But there's a big problem here. So there was a study in Nature that was conducted several years ago that found that more than 70% of researchers have tried and failed to reproduce another scientist's experiment. And then more than half of those have actually failed to reproduce their own experiments. We probably all have this experience at some point of doing some complex analysis on our phone calculator. We get to an end result and we cannot go back and replicate it. Okay, we can't go back and reproduce it. We all have this experience, right? So this is a problem. And a large portion of the scientific community recognizes that, yes, at least there's a slight reproducibility crisis, where more than half saying, yes, there is a significant crisis. And fortunately, there has been significant attention on this topic, both in geography and outside. So many scholars across a number of different domains are paying attention to reproducibility, replicability issues. We call this R&R for short sometimes. And recently, there have been several special issues in high-profile geographic journals like International Journal of Geographic Information Science, Cartography and Geographic Information Science. So there's quite a bit of attention on this issue. And with regard to analytical procedures, there have been a lot of improvements in this regard. So frameworks like Jupyter Notebooks, R Markdown, and Cordo help alleviate some of these problems associated with reproducibility, where we can actually weave our prose, our writing, and then weave that with our analyses and then have it spit out a nice looking document. And so this helps us get around the problem of having to copy and paste p-values, for instance, from some sort of statistical output and then put that inside of the paper. That's an error-prone process, and as analyses change, those values might change. They might not all get copied over, but using this approach, we can actually see all of those p-values directly from the analysis pop into the paper. And if the underlying data changes, that's fine. Just run the analysis again, and those p-values, those statistical results will populate in the end paper. So there's been a lot of improvement in terms of analysis. But my question is, what about data collection? So can we make data collection processes more reproducible? Can we make those replicable so that we can apply those to new questions? Now, we think about some forms of data collection, like maybe we're doing a lab experiment, we're getting results in a chemistry lab. It might be pretty easy to sort of reproduce that procedure. But what if we're working with human subjects? Okay, we go out and conduct a survey, let's say on 100 people, and then we conduct an analysis and we publish the results. If we wanted to reproduce that study, we would just apply the analytical procedures to the data, and everything would work out great. But what if we wanted to reproduce that act of actually going out and surveying people? If we surveyed the exact same people in the exact same way, we're never going to get the same responses twice. So there is a certain inherent e-reproducibility in terms of data collection, but there are a number of ways in which I think we can actually improve our data collection procedures. And so as we think about working with secondary data, data from the US Census, or working with satellite data from Sentinel or Landsat, we can use APIs, use API calls, and just record those API calls so that other people can take that data collection procedure and just simply reuse it. With primary data, it's a little bit more difficult. So I am going to talk now about this project called Replicable and Extensible Spatial Data Acquisition. And in order to address this challenge of working with human subjects, particularly with people annotating maps. We think about community surveys and how people perceive of space and place. This is something that I've done a lot in my time here at UWEC. I created a little R package called Map Survey that helps us get over some of the hurdles associated with the manual labor involved in taking in responses, scanning those, digitizing them to try to automate this a little bit more, but also enable extensions so that we can ask new spatial questions using very, very similar web survey. So this map survey package uses the R package Shiny, which is R's web framework, along with DeployR and a number of other packages. And I'll just give you a couple examples here. So kind of a classic thing we do as human geographers, particularly in class, is we ask people about their perception of region. So what do you perceive the Middle East is, right? So there's no like set definition. You're going to see different responses based upon where a person's from, their exposure to the region. And so inside of this map survey package, we have a function called perceptual regions, allows us to specify a region where we want the map to be centered and then a zoom level, and then the instructions will populate here. But we can also change the instructions and change the region if we're interested in studying a different location. So this is a question I asked in a previous research project. What do you perceive of the Midwest of the United States? And so this package is extensible in that it allows us to explore new spatial questions. Now, there's a lot that's kind of hidden from view here. I don't show how actually the data is being stored. All that's kind of happening behind the scenes. But this allows us to keep a very, very controlled survey environment, and then we can actually survey different groups in this way. We can extend this approach and address new spatial questions. And so this doesn't need to be just restricted to the study of perceptual regions. We could also study communities and how they perceive of areas perhaps needing urban redevelopment or funds dedicated towards certain pieces of infrastructure. So this is another approach that we can do by modifying the instructions argument here. Now, something else that I've done is survey students on how they perceive various regions of Wisconsin or various regions of Minnesota for certain purposes. And so there's a function inside of Map Survey called region rating. And what this does is it requires a state FIPS code. So in this case, I'm using 55, which is the FIPS code for Wisconsin. And then it takes the counties of a various state, and then we specify a number of clusters, and it'll create regions out of these clusters. And so this uses k-means clustering, which is going to produce a different result every time based upon where those initial points are determined by the algorithm. So we can experiment with different random seeds, and if we find a region configuration that we like, we can fix that seed and then use it going forward. So this one, as a default, says rate the following regions of Wisconsin based upon their desirability for things like eco and agro-tourism. And then users can go in and change these sliders, hit done, and then it'll store the results. But we can extend this to other questions and other locations as well. And so maybe we're interested in how people perceive of residential desirability in a place like Iowa. So uses a different number of clusters. 8 is maybe more appropriate for a smaller state rather than 10, different state FIPS code. And then we can also change things like the base map. And if we really wanted to, we could keep everything else consistent except for the base map and see how base map differences actually change how people respond to surveys. So lots of opportunities for reproducibility, replicability, and extension through the map survey package. And so using this approach of map survey, I'm now going to show how I've used this in a tangible problem in the study of cycling safety perceptions here in Eau Claire. But first of all, why cycling? Why should we care about cycling? So there are a number of benefits, and as I look around the room, I know a lot of you are cyclists, or some of you I've been on many bike rides with before, so I might be preaching to the choir here, but of course, there are health benefits at the individual level, and also at the community level. It also helps reduce pollution, not just air pollution, but noise pollution. It's greatly reduced by cycling. There are many psychological and social benefits. It's great for kids in terms of developing their sense of locational freedom, helping them improve their mental maps, giving them an appreciation for nature. But there's also a growing body of literature which highlights economic benefits of communities that emphasize cycling. So, of course, at an individual level, if you're replacing a car with a bicycle, it saves a lot of money. But for communities in particular, if they emphasize cycling as a form of transportation, tends to cause property values to go up, tends to increase tax revenue, offers opportunities for tourism as well. And then also job creation, both in the short term and long term, there are more jobs created by cycling than other forms of transportation. So a lot of reasons why we would want to emphasize cycling, but the most formidable barrier to ridership is safety. It's not temperature, it's not hills, it's not precipitation, it's not snow or cultural factors, it's safety. If people feel safe riding a bike, a lot of people will. And so we have different pictures of infrastructure. These come from my experience in Portland, Oregon, riding around that city. Some places are great in terms of separating bicycles from pedestrian traffic, from the light rail system, from cars. You see a lot of people cycling on this kind of stuff, and others are not so great, right? So this is an area where the bike path kind of goes across this lane of merging traffic, and no matter how much green paint that you put out on the road, people don't feel safe, they're not going to ride. So if we can address the safety concern, then you're going to see more people riding bicycles. So this is a little bit more complex version of those simple applications that I showed earlier using the Map Survey package. This is actually an extension on top of what's currently available in Map Survey. But in this survey, respondents are instructed to select locations that they feel notably unsafe for cycling near routes where they ride in Eau Claire. And so we didn't just ask people to label the locations that are the most unsafe for cycling, because then everybody would just, put a point on I-94, which nobody actually rides there anyway, and they're not supposed to, and that's totally fine. But we wanted to know, where are people riding, and what are the unsafe locations where people are riding? And so as respondents are given the survey, they follow the link, they put a point on the map, and then some reasons pop up for each location. And so users can select these various regions. And then we also have a question on neighborhood of residence. And here we just wanted to be sure that the spatial responses weren't biased by where people live, that weren't just purely an artifact of the places that people live. So we wanted to control for that. And then there are a number of questions related to cycling safety perception and demographics. So this one says, how confident do you feel in your cycling ability? Assume 7 is very confident and 1 is not confident. How much does safety influence where you ride? Assume 7 is very much, 1 is not at all. How many trips do you take per week? How often do you wear a helmet? For what reasons do you ride a bike? And then some demographic questions related to age, race, and gender. And so this was the survey instrument that was used for this study. And the questions that we're particularly addressing here, are there significant differences in the perceptions of various demographic groups? And for this, we use inferential statistics, the Mann-Whitney U-test, which is the non-parametric analog to an independent samples t-test. And we can use the Mann-Whitney U-test if data is not normally distributed. So we use that method. And then what are the spatial patterns of unsafe points? And we use a variety of methods to analyze these results. So interactive web mapping techniques, things like heat maps. And then we also use a clustering technique called dbScan, which stands for density-based clustering for applications with noise. And then a spatial method called convex hull or minimum bounding geometry. So these are the questions that we're asking. And so in order to distribute this survey, back in 2021, we went and handed out these flyers around campus. We actually rode bike trails. Me and my research team rode bike trails kind of through town. We would just hand them out to people that we saw riding. We put these on bicycles all over town. We put these flyers up on campus, handed these out at local bike shops and coffee shops. So we just use snowball sampling. and convenient sampling in order to try to get the word out as much as possible. And you'll see the artifact of this in the demographics of respondents. But we wanted to try to get as high a participation as we could. So distributed the survey this way, both with a QR code and with a link. Works a little bit better on desktop than it does on mobile, but reality of today is like a lot of people are filling out surveys on mobile and using mobile phones for surveys like this. So try to go for a wide dissemination of the survey. And in the end, we had 99 individuals fill out the survey, and they produced 339 unsafe points on the map. And as we look at the demographics here, most of the respondents were white, as we would maybe expect in Eau Claire. The survey was a little bit male skewed here, so a few more men than women filled out the survey, but not too terrible, close to approximate numbers there. And by age, most of the people who filled out the survey were relatively younger, which would make sense if we're doing this around a college campus. So yeah, most people fall in that younger age range compared to the others. And so based upon what we found in the demographic results, the places that we could legitimately do comparisons happened to be with gender, because there were such small responses in some of these other sort of racial categories and other age groups. So most of our comparisons are by gender here in this study. And so as we look at level of confidence in cycling, we'll start with the non-spatial responses, and then we'll get to the spatial responses. So as we look at level of confidence in cycling by gender, we can see, generally speaking, men in the blue color here appear to be a little bit more confident in their cycling ability than women. So some small differences in the distributions here. And this is something that is confirmed by other research. So other research has found generally men are more confident on a bicycle. So this isn't terribly surprising here. We see influence of safety on the choice of riding locations. And we can see here, it appears as though women in the green color here, that safety is a little bit more of a factor in terms of where they choose to ride, which would make sense in the context of this question about confidence, perhaps. But this is where it gets interesting. Oh, number of unsafe points mapped by gender. Yeah, so this is relatively even between demographic groups. And so we see kind of a peak towards zero. So most users are not producing very many points at all, just a small handful. But there are people who produce a lot of points. So a couple of people produce like 40 to 50 points. And this is something that's called the long tail effect. So we see this with survey results. We see this with location-based social media, web-generated content in general, volunteer geographic information, that there's a small percentage of users that are producing the vast majority of the content. We call this the long tail effect. But we don't see tremendous differences here in terms of number of unsafe points mapped. Now, if we look at number of trips per week by gender, we see two totally different distributions here. So look at women first here. So their responses, the mode, so the most common response for women was actually in this 13 to 20 category here. And then we also see a peak over here in the 0 to 3 category. So we see this sort of bimodal distribution for number of trips per week for women. Right, so women are either riding very, very little or quite a lot, and there are a reasonable number of responses in this 20 plus trips per week category as well. But when we look at the distribution for men, we see something totally different. It's relatively uniform, like it's pretty much flat, almost an equal number in each one of these categories. And so we can plug this data into statistical tests to verify, are there significant differences? And in terms of level of confidence in cycling and influence of safety on choice of riding locations, yes, we see significant differences there between women and men. But in terms of number of trips per week by gender, we don't see a statistically significant difference there, which is important because cycling in the United States is thought to be a male-dominated activity, and most of the research indicates that that's the case. This is a departure from what's been found in a lot of the literature on the United States. Now, in other countries, that's not necessarily the case. So in the Netherlands, for instance, women actually cycle more than men. And other follow-up studies I've done seem to confirm this. So this actually might be changing for cycling. This may be no longer a male-dominated activity in the United States. So as we look at number of unsafe points mapped, again, no significant difference between women and men here. All right, so now going on to the spatial responses. We'll take a look at the heat map first, and I'm actually going to disable the heat map here so we just see the raw points. And so kind of back out here, we can see generally there are more points towards the center of town than there are towards the fringe, but we do see these points kind of extending up along Jeffers Road towards F Highway. We see points here along Highway 12, a couple of points here kind of south of 94, but more points towards the center of town. And this is where heat mapping is really helpful to give us a sense of density. So as we turn the heat map back on here and scroll in a little bit more, we can get a sense of the places where we might see some significant clusters. So the area along Water Street, quite a few points here, around the downtown area as well. This area where State turns into Washington, turns into Harding, we see quite a few points along here as well. And then we see other pockets of points kind of throughout the town. Now, to me, just sort of anecdotally, the most surprising thing about the survey was the number of points that were mapped here down by the mall, and then the number of points here at the confluence of Claremont and Highway 53. So as a commuter cyclist, like I ride my bike all over town, all over time, I will not go anywhere near this place on my bike. And there are a lot of points here, even around the mall. And the mall, this area down here is where statistically the most car crashes happen in town. I won't touch this place on my bicycle. So there are a couple of possibilities here based upon how that question was initially framed. So we said map points where you feel unsafe in areas near where you ride in Eau Claire. So there are two possibilities here. So either people are riding in these locations and they feel really unsafe doing so, or they're riding near these locations and they avoid them because they feel unsafe, but they would ride here if they could. So I think that's an important takeaway. As we look around the town, there are unsafe points all over town. So people are either wanting to ride in these locations or they are currently riding here. Okay, so moving on now to our cluster analysis. So the clustering analysis technique that we use is called DB scan, density-based clustering for applications with noise. And used in this context, it's a little bit more of an art rather than a science. We have to experiment with the minimum number of points and then epsilon, which represents the search distance. You have to strike a balance between not having the number of points too high or too low. If you put number of points down to 3 or 4, you'll see clusters kind of all over the town. If you put this too high, then you only see 1 or 2 clusters. So we had to experiment with this, these thresholds a little bit with this distance threshold. This is a search distance for how far the algorithm will search for nearby points that it'll add to the clusters. But from here, we can see pretty clearly, large cluster here along Summit Avenue into Water Street. We see a little cluster down here, kind of around the YMCA, where Washington turns into Harding, and then another cluster around downtown. And so a lot of mixed land use in here. These are highly trafficked areas as well. But then we also see a sort of circle of clusters at these intersections, at these various intersections. And this is a place where I ride quite frequently, kind of around the roundabout here, next to the Quick Trip, kind of going underneath Claremont here down to campus. But some of these intersections over here, like this is a place that I would not ride my bike unless I absolutely have to. So I avoid locations like this and avoid intersections like this. And in the paper, we spent some time talking about in detail the infrastructure that's present at each one of these locations. But gives us an idea of where the city might want to focus its efforts on making locations more safe. And there are a variety of different ways in which that could be accomplished. All right, so now we're going to take a look at the convex hull. And this is where we do a spatial comparison by gender. And I'm just going to hide the convex hulls for a second so we can see the responses by gender. So here, for the unsafe points, points produced by men are in the blue color, points produced by women are in this green color here. And so as we look at these responses, we can see these points that kind of extend to the north. Okay, these are produced by men. Points that kind of go out here towards the east were produced by men. And I initially saw this and thought, okay, is this maybe just one user? And so we have a unique ID tag on each one of these users so that, yeah, we don't have one user that's sort of dominating the analysis to sort of be careful of that. But what's interesting here is the points that are produced up here, along with the points that are produced in this area, we can see these are all unique users actually. Points produced here, that's a different user. The points produced out here. So these are 4 unique users, 4 unique male users that are producing points at the outskirts of the city. And then we can use this technique of convex hull and use this minimum bounding geometry by gender to see the spatial extent of responses by gender. So this tool will produce a convex polygon of the maximum extent of all of the points. And we can see here that the points for men extend quite a bit out from the convex hull for women. And if we apply this convex hull for men here, we could see that just barely we look at the edge here, the convex hull for women is completely encompassed by that of men. And so we didn't necessarily ask our respondents about the maximum extent of where people ride, but this does seem to speak to patterns of gendered mobility. And as we think about transportation from an equity perspective, if we want our areas of the cities to be accessible for everybody, this should inform how we make infrastructure decisions. And of course, we could say that, oh yeah, in theory, and anybody could ride wherever they want, but in reality, not everybody's doing that. So that was a salient takeaway as well. So some of the major takeaways from this research, there are significant differences in perceptions of cycling and things like confidence and how safety affects where people ride, and then also the aggregated spatial extent by looking at convex hulls. So we see these differences by gender, but women and men take a similar number of trips by bike, which to my knowledge has not been uncovered before in the United States in a study on the US. And then we see clusters largely at intersections and mixed use corridors. This doesn't mean mixed land use is bad. It just means these are highly trafficked areas. And we ought to think a little bit more about how we can make people feel more safe there, either through traffic calming measures or through separated infrastructure and other strategies. So back to the reproducibility and replicability piece. Now that I've done this study in Eau Claire, what I've done more recently is in summer of 2024, traveled to Marburg, Germany, and I've implemented a similar version of the study in Marburg. So Marburg is a city that's close in population to Eau Claire. It's about 70,000 people in the state of Hessen, just a couple hours north of Frankfurt. And of course, this is in German. We have a German version of the survey and an English version as well. We eliminated the question about home location because the EU privacy laws, the GDPR, are a little bit more stringent than those in the US. So we eliminated that question. We also feared that not as many people would actually respond to the survey if we had that question. So we eliminated that one. But we did add another question. So my collaborators in Germany were interested in how we might see this play out for people who ride with children. So we added a question about whether or not people ride with children and how often they ride with children. And so we extended that initial study in Eau Claire and have applied that to Germany. And then this past summer, I traveled to Finland. And this is a study that we're hoping to get off the ground here within the next couple of weeks, where we're conducting a study in Tampere in Finland, which is a couple hours north of Helsinki. So applying this approach in Finland as well. And the point of this is not just to repeat the same study over and over and over again in different locations, but if we can get enough data from different spatial contexts, we can maybe start to understand what are the similar things that are in common between countries, and then what are the sort of unique elements of safety perceptions that we see between these places in order to get a better understanding of process. So that's kind of where I'm going with this in the future. So I've collected the data for Germany as well. Haven't collected data for Finland yet, but hopefully that'll happen here pretty soon. And with that, I'm finished with my presentation. Happy to address any comments or questions. So thank you very much. Yeah, Margaret. Sure.
Different, limited, and I don't remember how you framed your safety, but you probably focused a lot on, the layout of intersections, et cetera, but there could be a gender issue in terms of just broader safety, feelings of safety factors in terms of, especially if I'm by myself, I may not, as a woman, want to be riding way out on rural roads alone. I mean, that's just me, but it could be that it's broader than the kind of physical infrastructure of where I'm riding. Could limit my, sort of geographical area where I want to go. Not because I'm not interested in some of those areas, but it might just be a broader safety.
Yeah, that's a great point. Just to try to summarize the comment question for the audience. So with women in particular, there might be kind of a broader safety concern spatially, and actually maybe it makes more sense to go to the convex holes here. That women, it's maybe not that they're not interested in riding in these locations, or it's maybe not infrastructure in particular, but just sort of safety in general. Yeah, that's a great point. I do wonder how this would play out in a place like the Netherlands, where you see women actually riding more than men. Is their spatial extent still restricted, or do we see relative parity? That would be really interesting. Yeah.
Building off that, I'm curious if your research or the research you've read, speaks to the fact that, when I look at that graph, I think women are riding get from point A to point B for their specific this, and men are riding for, right, it's a weekend on a Saturday, they're way out of back. So I'm curious if the research has delved into that at all.
Sure, that's a great question. So the question was about reasons for why people ride, if there's a gender difference between women and men for trips for recreation versus transportation versus exercise. We did have a question in the survey about why people ride. So for what reasons do you ride a bike? Select all that apply. And I can't remember what results we found, but in the paper, we were bumping up against the word limit, so we didn't actually get to delve into differences between gender. But yeah, generally speaking, men tend to ride more for recreation and exercise than women do. And that's pretty well documented. And transportation too, in the United States at least. Yep. Yeah, Sam.
Because you mentioned that your paper or your survey found that frequency is after the point. But past research hasn't found that. Do you know if that past research more asked about safety growth? Because like, if theoretically like women are more scared to like be in areas further from the city, and they're using it more to commute, like.
Yes, that's a good question. So just to repeat here, the question was about differences in trips for women and men, whether it was about distance or about trips. The previous research I've seen has said particularly the number of trips is significantly different. Now, as we look at these distributions, I would argue these distributions actually are different in terms of their shape, but in terms of like raw number of trips from the non-parametric test result perspective, there's not a significant difference in total number of trips. But yeah, I'm not sure about previous literature on distance traveled, but I would anticipate there might be a difference there as well. So yeah, Ryan, do you?
Yeah, can't remember if you said this or not. Do you have a sense of what I don't think you asked it, but what do you mean by unsafe? Like, do you have that? I can't remember. I've seen this before.
Yep. So it's a pretty broad definition. And so we have a list of reasons why people might feel unsafe: lacking or poor infrastructure, traffic proximity, traffic volume, traffic speed, poor visibility, conflicts with pedestrians, hills. The traffic ones were the ones that were most common. Yeah.
My fear around campus is everyone on their phone in the car.
Sure.
That's why I ride
Mhm.
I walk and scares the hell out of me. That's
Yep.
cool. I forgot that you had that. Thank you.
Yes, and when we did this, the survey in Marburg, we actually found quite a few points that were on separated trails, right? So like areas like this, and we anticipate that's because these are areas where there are a lot of pedestrians for potential conflicts with pedestrians. So it's going to play out different in different areas of one city, but then in other countries as well. So yeah. Oh, sure, Matt.
With this testing method, you can put in as many questions as you want, or you said you were limited by word count, or?
Yeah, so the question was on limits to how many questions you can put in. So in the software itself, you can put in as many as you want. It's super flexible. So we can add as much as we want. The word count limit had to do with the paper that we submitted. Typically papers have a cap of, 5,000 or 8,000 or 10,000 words. But one thing that we need to look out for in a survey like this is something called survey fatigue. So if people are filling out a survey and they keep clicking next, and 30 minutes later, they're only 20% through the survey, they're just going to scrap it and not complete it. So there's a balance there between trying to get as much information as possible with not wearing out the participants. So.
You could also ask them to drop points of where they enjoy riding their bicycles and where they feel safe riding. You could ask them survey questions like, why do you feel that way?
Sure. I mean, yes, if we wanted to make this into an extension study, change it to places where they enjoy riding and change it from a point to a polygon. And they could actually circle different locations or perhaps even add routes. I mean, there are a lot of, different avenues for this. So, yeah, Nathan.
Getting to like that they keep on the point everyone's safe. Things are like being further research into like how much each of those reasons, potential reasons, like weigh into their considerations for being unsafe. Like for example, being like I honestly can't read that, but, like.
Yeah, let's see.
for
Can I
example,
actually zoom in
like,
here?
of traffic, especially more unsafe than like interrupting pedestrians, like, if there's a difference. Wait, I guess.
Sure. Yeah. So the question was about weighting these responses. So perhaps respondents would feel more unsafe around traffic than they would around pedestrians, or maybe it's a different kind of feeling of unsafety. In theory, you could put a slider on each one of these, right? And say like, how concerned are you about this element? And have a slider there too. So yeah, that's something that could be done. Oh, yeah, Erica.
I have kind of a two-part question. One, why not choose other US cities for this study? Why did you choose European cities? And then related to that, what was the process for human subjects approval like in those cities or in those locations?
Yes, this is a really good question. So one reason why I picked Marburg, Germany is because, well, first of all, our university has a partnership with Philipps University Marburg. So there was that sort of natural connection. And I wanted to explore a place that had a completely different historical context, also completely different laws as it relates to transportation to see how results would compare in a totally different context. Because I anticipated that there would be very, very different reasons why people would feel unsafe and different infrastructure characteristics. So that's one reason. And in the case of human subjects, of course, we have IRB. It's here on campus. So doing the study, we went through the IRB. That's a pretty smooth process because everything is anonymous here, and it's not too invasive. In the EU, it's yeah, the situation is a little bit different. For a survey like this, we didn't have to go through like a formal IRB procedure because we're not storing any cookies. We have no identifying data. And so it was actually a little bit easier that way. So there wasn't like a formal IRB form. There's just somebody that had to look over it and say, okay, yeah, this looks fine. But if we were going to be like caching IP addresses or email addresses or something like that, the process would be a lot more stringent. There are specific laws as it relates to where the data can actually be stored. So right now, all this data is being stored on an AWS server in the northeast of the United States. And like that would have had to been changed to the EU if there was any like personal information that was stored. So yeah, it's interesting comparing different IRBs between countries. So yeah.
I would love to hear if you've been able to bring this data to our, City of Eau Claire engineering. I know I've had conversations in the past with them, and they've been, they were concerned, they're like, the cost of painting a bicycle lane is really, really high, and it's like, okay, there may be an added cost, but the cost of the road and the rest of the infrastructure for the rest of the cars is higher than that, and they seem to be interested in supporting it, but feel really pain. So I'm curious how that's gone for you.
Yeah, so the question was about connections to the city of Eau Claire. I have reached out to the city of Eau Claire a couple times, letting them know about this research, and I have probably more connections at West Central Wisconsin Regional Planning Commission. But yeah, I would love to give this talk to the city, to planners in Eau Claire, to the engineering department or planning department. So if anybody has any connections that way, I would love to deliver this, or even to the city council. But yeah, I haven't heard back from them yet, so maybe someday. Okay, yeah, yeah. That'd be great. Yeah, and on your question too about the cost of painting a bike lane, yeah, I think this needs to be viewed as an investment rather than just a sunk cost. We spend the money and it's gone. Because if you really invest well in cycling-based infrastructure, it'll probably pay for itself in the long run. So, yeah, Liam.
So do you think you would ever consider pursuing a survey of like a specific section of a US city that was planned urbanly independent of like automobiles?
Yeah, so the question is, would I consider studying a city that was planned independently of automobiles? Yes, I certainly would, although it's tough to find those places. So think about Savannah, Georgia, Philadelphia, maybe. So yeah, it would be interesting to see. Yeah, but even in those places, even though the planning happened beforehand, and we can still see evidence of the Oglethorpe plan and William Penn's plan for Philadelphia, these places have still been heavily, heavily influenced by cars after the fact. So, yeah. But it'd be a great master's thesis topic. If you want to take this and go do that, by all means, yeah, go for it. Yeah, Sam.
cities that were car focused that got more transferred to bike focus. I think of like Riverside and Minneapolis.
Yeah, so the question is on cities that have been more car focused and are now emphasizing more cycling infrastructure. Yeah, that would be fascinating. Yes, I do think there is a challenge with large cities and that it might be quite a bit different than what we see in Eau Claire just because of the size of the city. And I really think Eau Claire is pretty darn good for cycling infrastructure. I mean, comparing it to other similar sized places around the country, it's one of my favorite places to ride a bike, if I'm being honest. So, yeah. Margaret, yeah. Hmm.
They, like, you're talking about weights and all that. You've got in other categories, this is more just a technical question. Can you actually allow people to fill in like, the text box, that they could check that and then indicate and or add a few more categories possibly to responses?
Sure. So, yeah, the question was on for this other category, could we make this open-ended and make it a text box instead? Yes, we could do that. Yes.
Perspective, but you could get some interesting insight.
Yep. Yep. And we did consider this. It is a little bit tricky because so this web framework, this is ours web framework, but all of this interactivity stuff here. So when you click the map and these reasons pop up, this is a JavaScript that's kind of built on top of ours web framework Shiny, which is actually built on a lot of JavaScript to begin with. So it got to be pretty complicated. You can certainly do it. And just from like an analysis standpoint, if we think about organizing the data as tidy data, rows and columns, one of those columns would be other, and if the person didn't check it, it would just be an NA. And if they filled it in, it would just be filled in with whatever that text is. So one thing that we were actually thinking about doing as a follow-up to this study is doing a focus group to actually get cyclists from different demographic groups and actually sit them down and say, okay, let's talk about these locations that you labeled, which I think would be a better approach. And of course, having more data is never a bad thing, right? So putting in this here, but I think, yeah, doing a focus group could get more at like what are the particular reasons why people are unsafe at those locations if they're not listed here. So yeah.
I don't know if that's necessary, but this is really cool research. Thank you for presenting.
Thank you very much.
I'm really curious, so you did this in 2021 and
Mhm.
I think even since then, we've seen like this continued proliferation of e-bikes, e-scooters and these,
Yes.
sometimes, you know, really useful, but sometimes dangerous forms of transportation and micromobility. And I'm curious, if you are tracking that moving forward or what you know about.
It's a good question. So the question was about e-bikes and micromobility like scooters. So on the survey in Germany, we actually included a question on the type of bike that people ride, whether it's a road bike or a mountain bike or a gravel bike or an e-bike or a cargo bike. So we actually did include questions on that. So we are exploring that in Germany. Then also in Finland as well, we had that question about the type of bike that people ride because yes, like e-bikes have really exploded. I was in New York City several years ago and like riding a bicycle kind of around Manhattan on the trails there. I mean, the e-bike situation is like out of control. I mean, people are, yeah, I mean, people are swerving like in and out of traffic. I mean, they're crossing roads diagonally when there's a red light from one direction. Yeah, so on the e-bikes, I definitely see a place for them. So my wife has an e-bike. I mean, that's how she pulls our little kids around town. And I think e-bikes can be a great option for a lot of people and also for places like Astoria, Oregon, for instance. So I have a friend out there who said, oh, Astoria is never going to be a cycling city because it's too hilly. Well, I mean, that's a place where e-bikes could really potentially like fill a gap for people who need to go up and down the hill. So I see a lot of potential there, but yes, there are some definite safety concerns. Another issue I see too is with people like inexperienced riding who think like, okay, I'm on an e-bike now, and so I can, kind of go do whatever I want, or on a scooter, for instance. The number of people crashing on scooters is not good, obviously. So okay. Yep.
And get myself home.
Yep.
I got
Yep. Okay. Yeah. Yeah, and there's a lot of research that indicates that like, some people say, well, e-bike's not exercise, but there's some research that indicates that people who are in e-bikes actually spend a longer amount of time on the bike. Like they burn more calories because they're going to stay out longer. They take longer trips. So there are some really good things about e-bikes, but yeah, definitely some concerns too.